Today is week 4. The lesson is the theory of consumer choice. Now, the previous lessons we discussed the demand curves, market forces, demand and supply forces, the factors, determinants of demand, determinants of supply, then the equilibrium, the meaning of equilibrium, then the government intervention into the market economy. Government can intervene by imposing ceiling price or the floor price. After that, we discuss the third lesson. We discuss the elasticity, how elastic the demand, how elastic the supply. Then we discuss various some quantities measures of elasticity, price elasticity of demand, then income elasticity of demand, cross price elasticity of demand, and the price elasticity of supply. Then there are determinants, uses we discuss. Now this lesson we discuss will go behind the demand curve. Now we know that consumers represent the demand side of the market. Then we can ask a question: how does a consumer allocate his income, limited income, among goods or among services, among goods and services? What are the factors, the determinants of his decision? What factors he mainly consider? Because your income is limited, prices you cannot control, you are a price taker. Then we have to have some rules, some model about the consumer's behavior. Now that's what we are going to discuss here, the theory of consumer behavior. How does a consumer allocate his income, that is a limited income, to purchase different goods and services? Now why do we here we have to ask the question, why do we consume? Objective of consumption. We drink, we play, we swim, we sleep, we eat, we entertain, we watch TV. What is the objective of consumption? Objective of consumption. What is the objective of consumption? Can you answer? Objective of consumption? Yes? What is the objective? Tell me. Yes? Objective of consumption? Yes? Hello? Why do we consume? Why do we eat? Why do we drink? Why do we sleep? Why do we watch TV? Yes? All are consumption. Get some satisfaction. Satisfaction. Pleasure. Satisfaction. In economics, the technical term for this satisfaction is the utility. We consume to derive, to get some utility. That is the one important thing in this theory. Utility. What is utility? What is satisfaction? What is utility? There are various definitions about the utility, but generally we assume it is the satisfaction. It is the satisfaction. Then the second question we are, can we measure utility? When you eat 2 chocolates, how many units of satisfaction? How many units of utility? 3 chocolates, how many units of satisfaction? Like that, can we measure? So the economists, when they develop this, the model about the theory, about the consumer, they first, initially they assume, yes, utility can be measured. Consumer can assign numbers to his level of his satisfaction. Utility. Based on that assumption, in other words, we call it cardinal measure of utility. Utility is measurable. They develop the theory. This is how consumer behave. This is how the consumer take decision regarding his expenditure on goods, buying of goods. Second theory assumes, that is called indifference curve approach. First approach is marginal approach, classical approach. Second is indifference curve approach, modern approach. They think That's a very realistic, rational the assumption. Economists, when they develop the theory, they assume consumer cannot assign numbers. Utility is not measurable. But consumer can rank different bundles. I like bananas to the chocolate, chocolates to the apples to oranges, like that. He can rank different situations, different bundles. That is called ordinal approach, order according to his preference. The ordinal approach, that is called ordinal measure of utility. Cardinal, ordinal. Then there are two theories. Theory or the model based on cardinal measure of utility. Second, the approach is the model based on ordinal measure of utility. Right? Ordinal measure of utility. Then, now we discuss here, first we'll discuss generally what is the first approach, marginal analysis, the measurable utility, the two concepts, total utility, marginal utility. Two concepts, total satisfaction, marginal satisfaction. So for example, suppose a consumer eats 5 oranges. The total satisfaction he gets from this is called total utility, TU. Suppose he now consumes an extra orange, one more orange. Well, he has 5 oranges, now he has one more orange. The extra satisfaction he gets from consuming the 6th orange is called the marginal utility of the 6th orange. Marginal utility. For example, let's assume first 5 oranges gave him total satisfaction of 100 utils. When he eat 6th orange, all 6 oranges gives him 110 utils. First 500, then next they are all 610. Then what is the marginal utility of the 6th orange is 10. 110 minus 100. 110 minus 100. That is 10. The marginal utility, satisfaction, pleasure, utility of the last unit, marginal utility. Formal definition is when you define is the marginal utility, it is change in total utility 110 minus 100 divided by delta Q, change in quantity 6 minus 5. 6 minus 5. Numerator you have change in utility 110 minus 100 divided by 6 minus 5. That is marginal utility. TU2 minus TU1. TU2 minus TU1. So therefore, when people take decision, they consider not only the marginal utility, total satisfaction, and the marginal satisfaction, marginal utility, the utility of the last unit. For example, at this point, now its time is around 10:41. This 10:40 to 10:45, 5 minutes time. Marginal utility of this 5 minutes. Right? Marginal utility of this 5 minutes. If you take marginal utility of this 5 minutes doing another thing, getting a good sleep. Maybe you will some of you are maybe lying on the bed, right? So that 5 minutes utility, 5 minutes utility of listening to my lecture, 5 minutes utility of lying on the bed, sleeping, half sleep, half awaken. So marginal utility of that 5 minutes. So that is you compare these two. Marginal utility of listening of this 5 minutes listening to my lecture is higher than marginal utility of the 5 minutes of lying on the bed, then you will listen. If other way around, you will get half sleep. Right? Now take this example. There is a marginal utility, but when people decide, take decisions, they consider total utility as well. Take this example. See this example. A consumer was asked to choose between giving up completely, underline that, either consumption of water. They choose, okay, we ask him to, okay, you stop drinking water or visiting the Facebook, visiting the chat book, or you see the choice. Then what will happen? They will definitely take the decision. Most would choose to give up visit to the FB. You can't stop drinking water, no? Why is that? What is the reason? What is the reason? Stop drinking water, stop seeing the Facebook, visiting the Facebook. People definitely stop watching FB, browsing FB, right? Then why is that? That is one question. You have to explain that. Second is this. Second observation is, suppose now they were asked to, same consumer asked, choose between having an extra 1,000 liters of water. Earlier, completely stop drinking water. Now, additional 1,000 liters of water. Last 1,000 per week, or 1 extra hour visit per week. Okay, either then the choice is consuming 1,000 liters of water per week or extra hour visit per week to the FB. Then what will happen? That is definitely inconclusive. You can't say. Some people say, okay, I will go for the take this extra hour visit per week. Sometimes another consumer might say, I will take the extra 1,000 liters of water. Different answers. Some would like to go to FP. Some would like to take the water, 1,000 liters of water. But the first one is definitely clear. Almost all the consumers say, okay, we will stop visiting FB because the water is very important. Now we have to explain why. Answer to the first part A is clear. Answer to the part B is not clear, not predictable. Why is that? What is the reason? First one is total utility. Total satisfaction of water is definitely higher than total satisfaction of total utility of FP. Therefore, they compare the total utility. Therefore, they see water is very much important. You can't say it is essential. That also you can use that as the item. But the total satisfaction, essential means total satisfaction, higher than FB. Therefore, definitely they will stop seeing FB consume water. They will definitely consume water. But the second one is not clear. Why is that? It depends. It depends on marginal utility of 1,000 liters of water and marginal utility of the 1 hour extra hour per week of FB. For some of you, FB marginal utility of last hour, extra hour may be higher than marginal utility of 1,000 liters per week. Therefore, then you will go for FB. Take 1 extra hour of FB. Another consumer there may be, no. I need 1,000 liters of water. I value 1,000 liters of water. I get more marginal utility of 1,000 liters of water than 1 hour of FB. He will give for definitely the water. That's why it is unpredictable. That is the answer to the second one. Depends on part B, depends on marginal utility of two things. Now you can answer. You can understand these two concepts clearly. What is total utility? What is marginal utility? Right. Second, the example. Now here I have a problem because I have how to work out these the problems. Right. Calculate marginal utility. Now the quantity is, let's say, orange, or the yes, quantity is Q. First orange, second orange, up to 10 oranges. How to understand this? When he doesn't consume any orange, total utility 0. First orange, total utility 20. 2 oranges, total 35. 3 oranges, 45. 4 oranges, 50. Like that, 10 oranges, 53. Now you have to calculate marginal utility. How do you calculate? Change in total utility divided by change in marginal utility. Change in total utility divided by change in marginal utility. Change in total utility divided by change in marginal utility. Now I will go for this one. This thing 1 to 2. For example, if I will copy down this thing 0, 0. Quantity P 1, 10, 2, 35, 3, 45. Now marginal utility. How do you calculate? Changing this divided by changing this. Changing this divided by changing that. How do you calculate? Changing this 35 minus 10 divided by 2 minus 1. 35 minus 10 is 15. 2 minus 1 is 1. Therefore, 15 divided by 1 is 15. 15. Third one. 45 minus 35. 10. 3 minus 2, 1. Therefore, 10 divided by 1, 10. Like that. Then fourth unit, it is, I can't remember what is fourth unit utility, 50 or 55? Fourth unit, 50, 50, yeah, 50. 50, changing this, 5 divided by 1, 5. So, remember marginal utility, what is marginal utility? Changing total utility divided by changing quantity. TU2 minus TU1 divided by Q2 minus Q1. 45 minus 35 divided by 3 minus 2. Right. Now you can calculate this total utility, right? Yes. Right. Total utility. So marginal utility of the first unit 20, second unit 15, third unit 10, fourth unit 5, 50 minus 45 divided by 3 minus 4. Fifth unit 53 minus 50 divided by 5 minus 4, 3. Sixth unit 55 minus 53 divided by the 6 minus 5, 2. Seventh unit, 56 minus 55 divided by 7 minus 6, 1. What will happen then? Total utility continuously increases. You can see 20, 35, 45, 50, 30. When you increase the consumption quantity, total utility increases. But when you see marginal utility continuously decreases, 20, 15, 10, 5, 3, 2, 1, 0, minus 1, minus 2. When you calculate, I want to calculate this, complete the above table. Marginal utility. Draw TU and MU curves. Explain behavior of TU and MU curves. Right? What is the shape of this TU? TU versus the quantity. You have to draw this. If you draw this, it would be like this. Quantity versus TU. Diagram below, I will draw the quantity versus MU. You have to draw this 1 to 10. Like that, you have to go 1, 2, 3, 4, 5. You calculate to total utility curve 0, 0. It increases and then decreases. Something like that. Total utility curve. Marginal utility curve, you plot this marginal utility curve continuously diminishes 22 like this. Something like that. Total utility is maximum. Utility curve, if you plot to a scale, actually it is like this. Total utility increases, attain the maximum, then 0. Marginal utility decreases, 0, negative. When total utility at maximum point, marginal utility is 0. Maximum point, marginal utility is 0. When total utility is increasing, marginal utility decreasing, but positive. Total utility is decreasing, marginal utility negative. At this point, it is 0. Marginal utility is 0. Right? That is the shape. Mathematically. Now, mathematics is important, but it should be justified by the theory. Why they are so? When consumer increase the consumption of a good or service, total satisfaction increases, attain the maximum, and then decreases. But the marginal utility of the last unit continuously decreases. Mathematically you can say. But now this behavior is very important. Now here we are going to introduce this the very basic law in economics, fundamental law in economics. That law is true for the consumption of any good or service. That law is true for anywhere in the world. It is universal law. True for Sri Lanka, USA, Japan, India. It's a universal law. That law is called the law of diminishing marginal utility. The law of diminishing marginal utility. So this declining trend of the marginal utility curve is explained by this law. When a consumer increase the consumption of a good or service, the marginal utility eventually diminishes. Marginal eventually diminishes. That is called the law of diminishing marginal utility. Take any consumption of any good or service. Let's say this class. First 15 minutes, marginal utility of the first 15 minutes is very high. You are at home, having a good breakfast, then you are listening to this, marginal utility is very high. Second 15 minutes, marginal utility of second 15 slightly less. Third 15 minutes, you are sleepy, you don't concentrate, it's a bit boring, less than that. Fourth 15 minutes, fifth 15 minutes, like that, it continuously diminishes. That is human behavior, right? So marginal utility diminishes. The continuous day. So it comes to 0 also. One point maybe the 8th 15 minutes, it is 0. That means you don't get anything. That is 0. Marginal utility is 0. If I continue after that, your marginal utility will be negative. You get not utility, disutility. You are not happy. So the marginal total utility curve falling. The law of diminishing marginal utility. This is true for any consumption of any good, any service. Any good or any service, right? So that is attending this class. Take the Sri Lanka, democratic country, not only Sri Lanka, any democratic country, India. Once in every 5 years, people go for an election. Sometimes they might change the government. Why is that? So because of the marginal utility, theory of marginal utility. First year, just you came into power, people have very high hopes. So marginal utility of this government, of this Indian government is very high. Second year, third year, Indians are not happy. Fourth year, Indians are not happy. So then fifth year, maybe marginal utility is 0. Marginal utility theory works. Very important, the law in economics. You can say most important law in economics. Consumption of any good or service. It's true for the consumption of any good or service, while total utility is increasing and attain the maximum and falling, marginal utility eventually falling. That's very important. Why it is eventually falling? You might question this. That is very important. Why eventually falling? Eventually falling means marginal utility, it might increase here. Marginal utility might increase here. In this case, continuously diminishing. Marginal utility curve can be like this also. Marginal utility up to this point might increase, then diminishes. Eventually diminishes. Anyway, obviously diminishes. It might increase, but eventually diminishes. Increase, right? That means. So in a party, the when in a party, social event, people start drinking beer. First, the glass of beer or whiskey, second glass, third glass, it might increase marginal utility, but eventually it might decrease. Fifth, sixth, seventh, eighth, ninth, we don't know what will happen after that, right? Marginal utility definitely decreases, right? So this is true for any consumption of any good or service, right? Eventually diminishes. The law of diminishing marginal utility. Right. That is the question. Yeah, now you can complete this table. Draw TU and MU curves. This axis quantities TU. Next one, quantities MU. Explain the behavior of TU and MU curves. I have explained here that. Now I have the curve. You see the curve. Total utility and marginal utility curve. Total utility of consumption increases and attain a maximum point and then falls. Marginal utility curve continuously diminishes. Continuously diminishes. It might increase. Sometimes it might increase, but obviously decreases. That example, the social event, when people enjoying initially it might increase marginal utility of the increases, but eventually diminishes, right? Okay. Right. Now these are the sum. Right. The shape of the MU curve is explained by a fundamental law in economics, basic law in economics, very important law. The law of diminishing marginal utility. It states that when other factors are held constant, as consumption of a good or service increases, underline that marginal utility of consumption eventually diminishes. Obviously diminishes, but it might increase. By looking at the above two diagrams, we could observe when TU is increasing, MU is positive and falling. When TU is at its maximum, MU is 0. Let me see. Yes, at this point it is 0. When TU is falling, MU is negative. This is negative. Right. That is the thing. Sorry. Right. Next one. 1.3. Now we know what is utility. What is the difference between total utility and marginal utility? What is law of diminishing marginal utility? We said it is the most important law in economics. True for consumption of any good or service. Then now we are going to discuss utility maximization. Now we said consumers consume to get some utility, satisfaction. What is the ultimate objective of consumption? Ultimate end objective of consumption to get the maximum utility, maximum satisfaction. That is called utility maximization. We consume to get the maximum utility. That is the basic assumption. Basic assumption of marginal analysis is that consumers seek to maximize total utility. Underline. They want to maximize total utility, not the marginal utility, total utility. However, the consumer needs to consider not just utility, but also the cost to the consumer obtaining that utility. Because when you consume the hot dog, the objective is to get the maximum satisfaction. You can eat 2 hot dogs or 3 hot dogs to get the maximum. But you have to consider it is costly. You can't control the price of hot dog. Your income is limited. You have to consider the cost. That's why we say, however, the consumer needs to consider not just utility, but also the cost to the consumer of obtaining that utility. The cost depends on prices and quantities of the goods and its affordability, income to buy the good. Prices and quantities of the good. So the price of hot dog, quantities, whether you eat 3 hot dogs, 4 hot dogs, 5 hot dogs, or then 3 pieces of pizza, 2 pieces of pizza, 2 portions, 3 portions. It depends on the price and the income, cost. If the consumer regards extra water to have the same margin utility as the extra visit to FB, that example, then he ought to choose alternative water which is cheaper. For example, we understand that also if you think marginal utilities are same marginal utility of the extra visit to FB and alternative the extra visit to water, then he will go for cheap alternative. FB is expensive, then the water is not expensive. We assume it is free. If marginal utility is same marginal utility, he will go for cheaper one. Because water is cheap. If you get the marginal utility same, 1000 liters of water and the 1 extra hours of FP, suppose gives him same marginal utility, then how to choose? He will go think about the cost. Water is free, therefore I will go for water, even though marginal utility of the extra hour and extra 1000 liters same. That is the decision, right? Then utility maximization, cost depends on price and the price of the goods, quantities of the goods, and the affordability, income of the consumer. The consumer maximizing utility, very important. Now, what is our basic question? Initially, we asked the question, how does a consumer allocate his limited income between goods when he buys things? That was the question. Now we come to a very interesting point. We said consumer's objective of consumption is to get the maximum utility, maximum satisfaction. But he has to consider prices, quantities, and income, market constraints. Now, how do you allocate this income? How do you allocate your income to get the maximum utility? That is objective. Maximum utility. This is the rule. Allocate its expenditure or the income among goods, so that you can say it's the income. Within brackets, you can put income also. Income among goods, so that the utility of last rupee spent on each is equal. Now, this interesting condition we'll discuss mathematically. The condition. How do you interpret that? Thus, the obtained required to maximize utilities for any pair of goods, 2 goods X and Y. Let's assume that the bread and apple, X is bread, Y is apple. Now is limited income. We know price of bread, price of an apple. Then this is the rule. marginal utility at the utility maximizing point, at the utility maximizing combination, bread and apple, marginal utility of bread divided by price of bread is equal to marginal utility of apple divided by marginal utility of apple. That is equal. Equal. That is the utility maximizing point. At the utility maximizing point, marginal utility per rupee, marginal utility per rupee, and marginal utility per rupee getting from both goods per rupee, MUXO PX equals MUYO PY. Right? MUYO PY. What is MUXO PY? PX, marginal utility per rupee when you divide that by PX. The good is bread, marginal utility of bread divided by price of bread. If you spend a rupee on bread, how many marginal utility you can take? If you spend a rupee on apple, how many marginal utilities you can get? At the utility maximizing combination, this marginal utility, say, if you spend a rupee on bread, rupee on the apple, you are getting the same marginal utility. You will not deviate. At that point, you maximize as utility. Now let us work out one example applying the above condition and find the utility maximizing bundles. Now this is the question. Now this is there's a small problem how to calculate this. Wait a minute, I am waiting. Yeah, right. Let us work out now example. What is the condition? MUXO PX equals MUYO PY. Now these the numbers are given. Quantity, two goods X and Y. Quantity is 1 to 7. First unit of X gives 22. Second units of X, marginal utility, the total utility, marginal utility. MUX 20. Third unit of X gives him 16. Fourth unit, last unit, 12. Fifth unit, 10. Sixth unit, 4. Seventh unit, 2. Good Y. First unit 19, second unit 17, third unit 15, fourth unit 13, seventh unit 7. Marginal utilities are there. Now they ask the question what we are supposed to calculate yes. Price of X is given 2, price of Y is 1, I is 10, income, I is income. Price of X 2, price of Y 1, consumer's income is 10, right? Now, we have to calculate what is the question. Find the utility maximizing combination of X and Y. How much of X, how much of Y he will consume to get the maximum utility. Then what is the condition? MUX over PX equals MUY over PY. That is the utility maximizing condition. Now you calculate that. How do you calculate? Let me first take down these numbers. You have to calculate MUX over PX quantities. Right. MUX. I'll copy down 22, 20, 16, 12, 10, 4. MUY 19, 17, 15, 13, 12, 10, 7. Now this is the table. Now, how do you apply this condition? What is the condition? Condition is this: MUX over PX, MUX over PX, or MUY over PY, right? MUX over PX. Now we have to calculate MUX over PX, marginal utility of X divided by PX. Another column. Then MUY over PY. MUY over PY. You have to apply that condition. MUX over PX, 22 divided by 2. 20 divided by 2. 16 divided by 2. Like that, you do that. 12 divided by 2, 6. 10 divided by 2, 5. 4 divided by 2, 2, 1. MUY over PY, 1901, 1701, 1501, 1601. Therefore, 19, 1701, 1501, 1301, 1201, 1001, 701. Right. Now we have to calculate. What is the condition? Condition is this: MUX over PX equals MUY over PY. What is the? This is the utility maximizing combination. At the utility maximizing point, marginal utility per rupee on both goods same. Then let's see the condition that satisfy this condition. So the quantities that satisfy this condition is the utility maximizing point. Now you see marginal utility PX 11, 10, 8, 6, 5, 2, 1. Here 19, 17, 15, 13, 12, 10. 7. This is here it is 10. It's 10. 10. 10. Now combination. What is X? X is 2. This is X, no? What is the Y? Understand? MUX over PX equals MUY over PY. Combination 2 and 6. Utility is maximized. It is maximized. X equals 2, Y equals 6. That is the utility maximizing the combination 2 and 6. At 2 and 6, this condition is satisfied. That's how we take down this. The utility maximizing combination, right? You can see now the how to divide that. Then you can easily calculate the other things. Take down that you divide this table, get the table, and then we calculate MUX over PX, MUY over PY. Then find out the point where these two share. Corresponding quantities are the utility maximizing. You get maximum satisfaction if we consume 2 of X, 6 of Y. Right? Take down this, take down that. Then you can understand. Right. That is that. You take down that. Second question. Okay. Now you know that the table is when the table is there. We apply our condition to check get the utility maximizing combination. Utility per rupee is equal at that point. Now we have decided, we have found that he will consume 2 units of X and 6 units of Y, right? Now we will see the presentation, go to the presentation again. Right. Second question is what is the second question? Right. What is the total amount of utility received by the consumer at this utility maximizing total utility? Now how much he consumes? 2 of X, 6 of Y. 2 of x, 2 units of x, 6 units of y. Now, what is the total utility of 2 units of x? First unit gives him 22. Second unit gives him 20 from the table. 22 plus 20. That is 42 is the total utility of 2 units of x. Agree? Yes. First unit 22, second unit 20. You add these two, then that is the total utility of 2 units of x. 6 units of y. 6 units of y is first unit is 19, second unit 17, third unit 15, fourth unit 4, fifth unit 10, 12, and sixth unit 10. You have to add all these numbers. Then that will be the total utility of 6 units of y. How much? That if you add this 19 plus 17, the 16, 21, 21, the 23, 21, 24, 24, 26. You have to add these two. I will add this 19. 19 plus 17 plus 15 plus fourth unit gives him 13 utils plus fifth unit gives him 12 units plus 6 units 10 equals 86. 6 units of y gives him 86 units utility. First 2 units of x 42. Then what is the total is 86 plus 42. 86 plus 42. This is the total utility of x, total utility of y. 128. 128. That is 128. Now you can see on the board. On the board, this the calculation is there. TU, I will write it here. TU, x, 6 units of x is 42. TUY, 2 units of x, 6 units of y is 86. 128. That is the answer to the second question. 128. Total utility is 128. 128. Right? That is the answer to the. What is the total amount of utility? You know, utility maximizing combination is 2x, 6y. Then you calculate what is the total utility of 2 of x, total utility of 6 of y, then add these two. Total we calculated 128. 128, yes. Verify the two equilibrium condition. Actually, we have already verified that. MUX of PX equals MUY of PY. That is, we have verified. Then he spent all his income to buy these the two goods. That is the budget constant. He spent. His income is 10. 2 units of x cost him 4 rupees. 2 into 2, 4. 6 units of y cost him 6 into 1, 6 rupees. 4 plus 6 is 10. 2 units of x cost him 4 rupees. 6 units of y cost him 6 rupees. 6 plus 4 is 10. That is, income is 10. So he spent all his income only to buy these two goods. No savings, no borrowings. He is highly contented person. In a normal economy, people either save or de-save or borrow. But in this model, very highly unrealistic model assumption, we assume consumer spent all his income to buy these two goods. He has income 10 rupees. He purchased, spent all these 10 to buy this combination, utility maximizing combination, 2 of x and 6 of y. Right. That is the I think practice question. I have given some more questions. Now the second approach. Second approach, what is the indifferent? Now earlier we discussed marginal approach. Marginal approach assumes utility can be measured. Cardinal measure of utility. Now the second approach. Indifference curve analysis. This assumes Consumer cannot assign numbers, like numbers, give numbers to his level of his satisfaction. But he can rank different bundles. I prefer oranges to apple, apple to bananas, like that. He can rank different bundles according to his preference, utility, taste. That is the assumption. Utility is not measurable, or utility, the ordinal measure of utility. First approach, utility can be measured. Cardinal approach, you can assign numbers. Ordinal approach, for example, any two goods, oranges, apples. When he asked a consumer rank, he said, okay, I prefer oranges to apple. Apple to banana, he might say, I prefer banana to apple. Rank. So when you rank goods or service, you can either preferred bundles. A is preferred to B, or he can say B is preferred to A, or I am indifferent, A and B indifferent. Three possibilities are there. These are the assumption of consumers' utility, right? Now the indifference curve analysis, now we are going to discuss that in detail. Consumer behavior has three stages. When you analyze in this model, you have three components, three sections. First, we discuss what the consumer wants to do. He wants to get the maximum satisfaction, his preference. We discuss characteristic properties of his consumer's preference, taste, in the first section, stage 1. Next, we discuss his market environment. He has so many constraints. His income is limited, prices, he cannot control the prices, he is a price taker. That is called budget constraint, market environment. Third stage is the decision. What is the decision? How do you get the maximum utility subject to a budget constraint? That is the utility maximization. These are the three stages of this approach. Indifference curve analysis has three stages. First, we discuss properties of the consumer's preference. Next, we discuss his budget constraint, market environment, market constraint. Next, we will discuss how does this consumer maximize the utility subject to budget. Now, we all do these things. When you go to a department store to buy a shop, supermarket, or the one of these textile shops, you want to buy a shirt. You have limited income. Your budget is given. Then when you buy a shirt or sari or a blouse, pair of shoes, you buy things, maximizes utility subject to a pocket, subject to a budget. Very reasonable assumption of consumer behavior. Consumers in a market economy tries to maximize the satisfaction subject to his budget. Very reasonable assumption. That's what we all are doing. When you go to Sunday Cola or the supermarket or a department store, candy or Tilakavardhana, that's how we behave. That is the behavior. That is a very important behavioral assumption. Consumers maximize utility subject to budget. Right. Now, there are three stages. Now we'll discuss first stage, consumer's preference, taste, preference. What are the characteristics, properties, assumptions of the consumer's the preference? Now we specifically we can define preference, taste, utility. Here we assume same meaning, but in advanced economic courses you have some different mathematical definition. But here assume when you say preference or the satisfaction, utility, we think is the same. What are the characteristics, assumptions? Preference is complete. I will explain that. What is completeness? Assumption of completeness. Consumers, we are talking about consumer in a market economy, free enterprise economy system, in other words. Consumers' preference is transitivity. Third assumption is non-satiation. Now, these assumptions are very important. You have to understand and remember sometimes by heart, because we saw the question in this is 2019 or 18 September paper. There was a question, what are the 3 assumptions of consumers' preference? Explain briefly. That was the question. So we have to give these preference, assumption of completeness, assumption of transitivity, non-satiation. Right? Now we'll discuss this in detail. What is completeness? Assumption, consumption. Given any 2 bundles of goods, A and B, consumer should be able to rank, underline, should be able to rank or order the 2 bundles into one of the following sets based on his preference. Bundle A is preferred to bundle B. The greater than sign, the A greater than B. A is preferred to B. Bundle A and B equally preferred. A equals B. Or bundle B is preferred. B greater than A. Right? In terms of utility, what does that mean? When you say A is preferred to B, first one, you are getting more utility, more satisfaction from A than from B. When you say A and B indifferent, equal, you are getting same satisfaction, same utility from A and B. Then bundle B is preferred to bundle A means you are getting more utility from B than from A. Now, given any two bundles, let's say apples and the oranges, we give the consumer, give a ranking. What are the possible answers? He might say oranges, I prefer oranges to apple, or apple is preferred to oranges, or I don't mind. That's say indifferent. These are the only 3 possible answers. No any other answer. That is called completeness. Given any 2 bundles, any 2 goods, any 2 services, any 2 situations, consumer should be able to give his ranking. A is preferred to B, B is preferred to A and B indifferent, equal. Take 2 situation. Attending this class, IABF class, from 10:30 to 12:15. That is one situation. Or taking a flight to London. Take a flight to London. Right? These days, you don't want to go to London or any of these the capital cities of the European or the Western country because the COVID is still there. Right? Let's assume. So the take a flight to London, one situation, the attending BTI class, another situation. What is meaning of completeness? When I ask one of you to rank this, give you a preference, you can't say, oh, they are so different, I don't know. I can't classify. No, that is wrong. You should be able to give ranking. That's why I say any 2 bundles, any 2 situations, consumer should be able to give his ranking. I prefer to go to London to attend in this BTI class, or I prefer to attend BTI class going to going to London, or I don't mind, indifferent, attending this class or going to London, same, equal. Another, these are the possible answers. You should be able to give ranking. Rank this order to any of these one of these 2 sets, right? Preferred set or the equal set, right? A is preferred to B, B is preferred to A and B indifferent. Otherwise, you can't say, I don't know, they are so different. How come I say I rank this? I don't know, I can't. In that case, your preference is not complete. Understand? The preference is complete. Given any 2 situations, you should be able to rank. Right? The number 1. Second property of this preference is the transitivity. It is another assumption is called the consistency. Consumers, the preference should be transitive, consistent. Consumer should always be rational, consistent. How do you measure this consistency? For example, if you think, okay, orange is preferred to apple. Apple is preferred to banana. Orange is between oranges and apple. Orange is preferred to apple. Between apple and banana, apple is preferred to banana. Right? This should imply what? Oranges and banana, which is preferred to what? Oranges preferred to banana. Right? That is called transitive property. Oranges preferred to apple, apple preferred to banana. This should imply oranges preferred to banana. That is the consistency. Consumer can't say, no, I prefer banana to oranges. No. Then his whole collapse. His preference is not consistent. He is not rational. Oranges prefer to apple, apple prefer to banana. Therefore, without asking anything, if it is rational, consistent, oranges should be preferred to banana. If you say bananas prefer to oranges, then something wrong with his preference. Rational consumers, the preference should be consistent. A is preferred to B, B is preferred to C. That means A is preferred to C. Given any three bundles, A, B, C, consumer preference is such that, let's assume between A and B, if A is preferred to B, B is preferred to C, then bundle A should be preferred to bundle C. He can't say C is preferred to A. In that case, is not rational. The rational consumer should always take this consistency condition, comply with this consistency condition. Right? Similarly, if A and B indifferent, let's say oranges and apple, I don't mind. When people say I don't mind in terms of utility, that means you are getting the same utility. I don't mind A and B. B and C, indifferent. Then this should imply, without asking, that A and C equally preferred. Then only consistent, rational behavior. In that case, if you say A is preferred to C, then that is something wrong is the taste preference. So consumers, the preference should be transitive. Preference should be complete. Given any two situations, he should be able to rank. He can't say no, I don't know. They are different. No. Given any three situations, he should be ranked consistent way. Right? Consistent way. Yes. That is transitivity. Third assumption is very interesting. Consumers, we can discuss. Preference is non-satiation. That is non-satiation. Consumer always prefers more to less. More is preferred to less. More is preferred to less. That is consumers' behavior, preference. Always we prefer more to less. If you have 1,000 rupees, you want to get 2,000. 2,000 is preferred to 1,000. 3,000. 3,000 equal to 2,000. You always want to have more. One more. That is the assumption about the consumer's preference in market economy. Non-satiation, not satisfied. That is more is preferred to less. Right. For example, we can define in the case of goods. Now this point is very important in the A level, local A level. This question was there. I can't remember exactly the paper. Difference between a good and a bad. There are goods, there are bad. Pollution, bad. Garbage, bad. Unemployment, bad. Inflation, bad. Good. Apple, oranges, bananas, right? Love, good. We like that, right? Then that is the good and bad. There are goods and bad. Now, at this point, we can define, using this property, we can define a difference between a good and a bad. In the A level, local A level, that question was, what is the difference between a good and a bad? They had asked this question, difference between a good and a non-good, a bad. right? What is that? A good is a commodity for which more is preferred to less. That's a good. We want more to less. More is preferred to less. More is preferred to less. Right? Apple. We don't have more apple. 10 apple, 15 apple, 20 apple. We always prefer to have more and more. Income. $1,000, $2,000, $3,000, $4,000. We always more to less. That is, income is a good. More is preferred to less. Bad. Then what is bad? Then some spelling mistake is that then THEN. Then what is bad? It is a commodity for which less is preferred to more. Don't like garbage. We prefer to have less and less garbage, less and less pollution. We always prefer. That is, less is preferred to more in the case of bad. More is preferred to less in the case of a good. Less is preferred to more in the case of a bad, garbage, pollution, unemployment, less unemployment. Economy preferred less unemployment to the more unemployment. COVID-19 is bad. COVID-19 is bad. Why is that? We don't like COVID-19. We always want to have less and less affected people by COVID to more and more people of COVID. We prefer to have less and less number of people affected by COVID than to more and more people, right? That is the bad. COVID is bad. Why? You can explain, right? We get if you have more of COVID affected people, the patient, then you don't get utility. You are not happy. You are not the preferred. We always prefer the less to more. Early one, more to less, right? The consumption of bad, consumption of good. Right? In this analogy, we assume now in this whole model, we assume commodities. All commodities are goods. We don't use the bad assumption. There are textbooks, some advanced textbooks. You can analyze this the bad behavior of bad. Where people prefer less to more. But generally, we assume people prefer, consumer prefers more to less always, right? Okay. Now let's go back. Now we have three assumptions of consumer preference: assumption of completeness, assumption of the transitivity, assumption of the non-satiation, not satisfied. More is preferred to less. Let's discuss about the last thing. Always I discuss in the class. Combine this with some our normal understanding. More is preferred to less. About Buddhism, more is preferred to less. What is non-satiation? More is preferred to less. More is preferred to less. What does that mean in terms of in Buddhism? More is preferred to less. 1,000 rupees, 2,000 rupees preferred to 1,000. 3,000 rupees. When you have less, you want always more. What does that mean? In Buddhism, it is called tanha, greed. Greed. So the people in economics, we assume people in the market economy are greedy. More is preferred to less. Greedy, tanha, right? That is the assumption of consumers in the market economy. For Buddhism, Lord Buddha said something else. What is tanhaya jayati soko? Right? The greed results generate sorrow to the people. But in economics, completely different subject. What is that? Tanha, the greed. Yeah, you are greedy. You prefer more satisfaction. More satisfaction. Greed. Greed. Tanha jayate santutti. Satisfaction. Greed results happiness. Two things. Lord Buddha said, greed results sorrow. Economics say greed results happiness, utility. Then you can say Lord Buddha is you can't say it's wrong. No. Why is that? When you have more and more happiness, more and more happiness, more and more happiness means ultimately it will, marginal utility theory applies, sorrow, it is sorrow. Road visa is still correct. Very simple example. So the always, even though economics assume greed generates happiness, ultimately it is the sorrow, right? So these are the assumption of three assumption of consumers in a market economy: completeness, transitivity, and the most preferred to less. Right? Okay. Now we know. Now we are going to discuss more about the consumer's preference. Right? Indifference curve. You know, assumption of the preference. Now we are going to define a new term: indifference curve. Indifferent mean the word itself gives some clue. Indifferent, indifferent, equal, equally preferred. Now it's a curve. To draw the indifference curve, it is not here, it is there. When you draw the indifference curve, you take all this bundle Y, you know. This PDF tool lets you easily modify text and images. Well, I can't. Anyway, so okay, X and Y, those two goods, good X, good Y. Maybe apples and oranges. X is apple, Y is oranges. Right. Now these are the combinations. Combination of two. What is indifference curve? The locus or the line curve of all bundles, all indifferent bundles. Underline that. Indifferent means equally preferred bundles. 2 oranges, 3 apples. Then 20 oranges, maybe the 10 apples. Like that, you can give different bundles, form different bundles to goods, and we can ask him to rank. Some bundles he say A is preferred to B. Sometimes he might say C is preferred to D. Sometimes he say I am indifferent. I am indifferent. Large number of bundles is given to him. Then you take all these indifferent bundles. Two goods are there, no? X and Y. X and Y. Using this XY coordinate, we plot this curve. Plot this curve. For example, that curve is called the graph represent all indifferent combination of goods which yield the same, consume the same total utility. Now, for example, if you take this 100 utility 100 curve, indifference curve 100, all the combination of XY 1 and 10, maybe 5 and 5, then 2 and 10, like that. All these, if you can have different large number of bundles here, all these bundles, if you take each bundle gives him 100 units of service, so 100, 100, like that. This is your 100 indifference curve. Next one, combination along this indifference curve 200, you get him 200 utility, 200 level of utility. Each bundle gives him on this curve gives him 200 level, higher satisfaction. Higher the curve, higher the utility, 300 indifference curve. These bundles 300. So therefore, indifference curves are drawn using indifferent bundles, equally preferred bundles. You take equally preferred bundles, not the preferred bundles, and draw this curve. You can draw. You have XY, 100 utility. All the bundles that use 100, you draw that one, 100 indifference curve. All the bundles use 200 utility. Take bundles and draw the curve, right? Okay. Now, properties of the indifference curve. Properties of the indifference curve. I see. Indifference curve. Indifference curves do not intersect. Do not cross. Do not cross. They are parallel. Do not cross. Very important property. We can prove, remember all these 4 properties can be proved using our basic assumption, transitivity, completeness, most preferred less assumption, using these, 3 properties of this consumer's preference. We can prove All these the properties of indifference curve. Number two, they are negatively sloped. Higher the IC, higher the utility. 100, 200, 300. Higher the IC indifference curve, higher the utility. Third one, they are convex to the origin. This is convex shape. Concave shape is production possibility front is concave. This is convex. Uttala, avatala. Uttala means the concave. Production possibility front is concave. Generally, this is convex. Then actually he taught here in IBS a long time ago. He taught here, one of the lecturers, right? Then the indifference curves do not intersect. They are negatively sloped. Higher the IC, higher the utility. They are convex to the origin. Now, next one we will discuss. Now remember, all these four properties can be proved using our basic assumption. Basic assumptions of consumer's preference. That's very important, right? This stage we are not going to prove that. We'll discuss the basics and the practice question. I have given that. When we discuss the practice question, we can prove that. Right? Slope of an IC. Slope of the IC is called marginal rate of substitution. Remember, this name is very important. For the another the term concept you will come across when you discuss the theory of firm, that is called marginal rate of technical substitution, MRTS. But in theory of consumer behavior, we call it marginal rate of substitution. What is the slope of an the IC, the indifference curve? How to define? MRS between two goods XY equals change in Y divided by change in X. Change in Y divided by change in X. Still mathematics. We are not discussing economics. I will first define what is the meaning of MRS, the economics of this MRS. Right. MRS is now here slope of an indifference curve. Economic meaning is this. Slope of an IC is defined as marginal rate of substitution. It shows that the rate at which a consumer is willing to substitute good Y for good X to keep him on the same IC, enjoying the same total utility. I will explain that again. The MRS is 4. Let's say MRS, one of the between two goods for a consumer is 4. What does that mean? Consumer is willing to give up 4 units of Y to get 1 unit of X and maintain the same satisfaction. If MRS is 3, consumer is willing to give up 3 units of Y to get 1 unit of X and maintain the same total utility. You are on the same indifference curve, total utility. If for another consumer MRS is 2, he is willing to give up 2 units of Y, good Y, to get 1 unit of X to maintain the same level of total utility, and in other words, you are on the same indifference curve. Let's take this example. Now we have, it is consumer's willingness to substitute one good for the other. The consumer's willingness. Now we in the marketing, we are different because of our willingness to substitute two goods are different. We are unique. We are unique between the chocolates and ice creams. Substitution between chocolates and ice cream. To get 1 chocolate, how many ice creams? Or to get 1 ice cream, how many chocolate slabs you are going to give up? 2, 3, 4. Different consumers have different substitution, different rates of MRS. In a market economy, consumers are unique. Our behavior is different. Individual behavior, substitutability is different. Our willingness to substitute one for the other, to get 1 unit of the other, willingness to substitute good Y for the other is different. MRS is different. That's why consumers are unique. Okay. Now I have given some exercise. Bundles. 3 bundles, A, B, C, D, E, bars of chocolate, glasses of lemonade. This I got from one of the textbooks. Lemonade, the bundle A, 11 chocolates and 1 glass of lemonade. They're a very funny combination, but people eat chocolate and drink lemonade, right? Then bundle B, 7 chocolate and lemonade. Bundle C, 4 chocolate, 3 glasses of lemonade. Bundle E, 1 chocolate and the 5 glasses of lemonade. Now these are indifferent bundles. A indifferent, B to C to D to E. What does that mean? You are getting the same satisfaction, same total utility from each of these bundles. In other words, all these bundles should be on the same indifference curve. Agree? So they are indifferent bundles. Indifferent bundles, right? Okay, let's see. They are indifferent bundles. I have given that the question. Yes. This question. Draw the indifference curve taking glasses of lemonade along the x-axis and chocolate bars along the y-axis. Right? I have drawn this. You see now, one x-axis, the x-axis lemonade, no? Lemonade, yes. Lemonade 1, 2, 3, 4, 5. Bars of chocolate 11, 7, 4, 2, 1. Right? 11, 7, 4, 2, 1. Then you can see the 11, 7, 4, 2. Right? 1, 2, 4, 5. First bundle A, 1 lemonade, 11 chocolate bars. 2 lemonade, 7. Bundle C, well, C should be a bit above this. C, D, D, E is not there. No? C should be a bit above this. Mark this. C, 3 and 4. D, 4 and 2. E, please mark that. 5 and what? 5 and 1. Bundle E. Mark the 5 and 1. Right? Now these are the bundles. Right. Now what will happen? Let's now discuss. Let's assume consumer initially is at A. Now we ask him, okay, to get 1 more units of lemonade, move from A to B. That means you get more lemonade, 1 unit of lemonade. How many units of Y you are going to give up? 11 minus 7, 4. That is change in Y, change in X is 1, 2 minus 1. Change in Y divided by change in X. That is the delta Y, delta X. Change in Y, 11 minus 7. Here 11 minus 7, 2 minus 1, 4. That is the between A and B, MRS between A and B is 4. A and B is 4. 11 minus 7 divided by 2 minus 1. 4. B and C, between B and C, 7 minus 4 divided by 3 minus 2. That means 3. If the consumer at B, move to C. That means you are getting 1 more unit of lemonade. How many units of chocolate you are going to give up? 3. C to D. 1 more unit of lemonade, you are willing to give up only 2. Earlier 3. Initially 4. 4, 3, 2, 1. You are willing to give up. To get 1 more unit of lemonade, 1 glass of lemonade, consumer initially willing to give up 4, after that 3, then 2, then 1. Very interesting mathematically speaking. But we have discussed the economics of this one. Why is that? How to explain? Consumers' willingness to substitute good Y for good X diminishes. Initially, when you have less and less of X, you are willing to give up more and more Y to get 1 more unit of X. Initially, you have only 1X, 11Y. Then to get 1 more unit of X, your marginal utility of X is very high. Therefore, you are willing to give up 4 units of Y to get 1 unit of X. Now you are slightly okay. You have 7Y, 2 of X. Then you get 1 more unit of X, 2 to 3. You are willing to go up only 3. Initially 4, now 3. Then C to D, you are willing to give up only 2. Then D to E, you are willing to give up only 1. What will happen? When you move along this A to D, A to E, your willingness to substitute good Y for good X, good Y for good X diminishes. MRS diminishes along the indifference curve. MRS diminishes, slope of an indifference curve diminishes along an indifference curve. Slope of an indifference curve diminishes along an indifference curve. By that, still we are discussing only the mathematics, but economics, that is a very strong behavior. Economics, why is that? When you have less and less of X, you are willing to go up more and more of Y. Then when you are getting more and more X, more and more X, more and more X, more and more X, 1, 2, 3, 4, 5, more and more X, what will happen? Marginal utility of X diminishes. Law of diminishing marginal utility. Then what will happen? To get 1 unit of X continuously, your willingness to give up Y is diminishing. Why is that? You are getting more and more Y means your marginal utility diminishes, no? Therefore, that's not important. Therefore, your willingness to give up Y also diminishes. Very interesting. Then, along an indifference curve, slope diminishes. 4, 3, 2, 1. MRS diminishes. What is the reason? Reason is the law of diminishing marginal utility of good X. Because when you are getting more and X, 1, 2, 3, 4, 5, marginal utility of the last unit diminishes. Therefore, your willingness diminishes. MRS diminishes. Now we are very interesting, this mathematical observation and theory. Because mathematics, most of the people think economics is maths. No. Maths is economics. No. Economics is a unique subject. It's a philosophy. You can explain most of the economic concept easily if you are conversant with maths. Don't misunderstand. Mathematics is all economics. No, completely different, right? So therefore, now we have a link between the economics and the people, consumers' behavior and this diminishing MRS. MRS diminishes because of the law of diminishing marginal utility. Understand? You have to clearly understand. This was one of the questions. Explain why MRS diminishes along an indifference curve. What is the economic rationale behind this diminishing marginal rate of substitution? You have to explain. Give the explanation. I have given this. Right. MRS for consumer. Okay, take down this. I have not mentioned that. Anyway, take down this. The along an indifference curve. Take down that. Along an indifference curve, MRS diminishes. Along an indifference curve, marginal rate of substitution, MRS diminishes. Due to the law of diminishing marginal utility. Along an indifference curve, MRS diminishes due to the law of diminishing marginal utility. Explain. That is the question. Explain. Now, using this particular example, you can explain why MRS diminishes. 4, 3, 2, 1 decreases using consumers' behavior. When you have less of X, his willingness increases. When you get more and more X, marginal utility of X diminishes. Therefore, your willingness decreases. I want you to answer that. Homework question. Right? Homework question. Diminishing MRS. Right? Okay. Now, different shapes of indifference curve generally is convex to goods X and Y. But some special cases are there. Some special good X and Y are there's some specific relationship. Then shape of the indifference curve is different. Nature of the relationship matters. Then the shape of the indifference curve different, right? Let's say when two goods are substitute, perfect substitute. Two goods are perfect substitute. What is perfect substitute? Tell me example for perfect substitute. You might say tea and coffee substitutes. Agree. Then what else? What are the substitute? Bank service of HNB and service of a commercial bank substitute services. Good. Agree. Substitute services, right? Fish and the meat substitutes. In Sri Lankan case, fish and meat, chicken substitute, right? Then these are substitute. Then you have say local potatoes and the Indian potato, imported potatoes substitutes. Now I am asking perfect substitutes. What is a perfect substitute? Now it's very difficult to define a perfect. They are substitute. Some degree of substitutability. For substitute products, remember last time we discussed cross price elasticity of two goods is positive for substitutes. When the cross price elasticity is very high, 1,000, 2,000, 20,000, then they are perfect substitutes, very high. It is positive, very high. But perfect substitute is a completely different aspect. It's a 1-to-1, 1-to-1, 2-to-2, 3-to-3, like that, the substitution. Textbook example, I will tell you a textbook example to understand the perfect substitutes. Perfect substitutes. Now, for example, colorblind consumer. Let's say a person is colorblind. Who is a colorblind consumer? He cannot differentiate colors. Red, blue, green. He cannot differentiate this color. It's a genetical problem. So you can't differentiate colors. Now, most of the time you realize this color blindness when you start drawing arts or start doing titration in when you go to the lab, you go to the campus and start doing the titration. Then you in the titration, you have to see the color change. Color change, then you draw the when you draw the conclusion, titration. You can't do in the chemistry lab. I was one of my batchmates. We were together in the university. I did chemistry for my degree, first degree. Then all of a sudden, we went to this to start doing titration. Then one day he said, we always see the color change. Blue to gadol ratu. When the people is feeling some sugar, it changed. Blue to gadol ratu. This red. Blue to red. Blue to red. When the color changes of the titration, blue to red, we draw the conclusion. Yes, that it is having some sugar or some conclusion. But this guy said, I can't see any color change. All the time I see only one color. Then people start talking. We complained that to our professors. Then we identify he was diagnosed with colorblind the consumer. He cannot differentiate. Then he had to quit his course to physics or some other course in some same university but different subject. Definitely not the chemistry. So then what will happen? The color change. Colorblind consumer. Colorblind consumer cannot differentiate colors. For example, let's say colorblind consumer. Now we are going to discuss this the perfect substitute. So when we give him, I have a red pins, 10 red pins, and the 10 red pins, 10 blue pins, and 10 red pins. I gave this 10 red pins to the colorblind consumer. I am here with blue pins. If I give him blue pin, I can't say this is blue, but he can't differentiate. If I give him one, he might give you one red. I will give one, he will give one. I will give 2 blue pins without any preference, special taste. He will give 2, 3, like that. He can't differentiate. No? Understand? So the textbook example say for a colorblind consumer, red pins and blue pins. So either 1-to-1 or 2-to-2. If I give the 1, he might give 2, 2, 4, 3, 6, like that. Not always 1-to-1. It depends, right? So but he doesn't have special preference to the colors. He can't differentiate, right? So in that case, what will happen? Always substitutability is willingness to substitute same, either 1 to 1 or 2 to 2 or the 1 to 2 or 1 to 3, like the same. What does that mean? MRS, marginal rate of substitution, constant. Slope of the indifference score, constant. When the constant slope is there, it is a straight line. When the two goods are substitutes, indifference curves are set of straight lines, straight lines, straight line. You 100, you 200, you 300. So the colorblind consumer always substitute 1 to 1, 1 to 1, 2 to 2, 3 to 3, something like that. That is the example for the different shapes. Generally, it is convex. Convex. Now we have generally it's convex. Now we have the straight lines. Second one, we'll stop from the second. The next next week we'll continue. This one, different shapes of India. Perfect complements are the extreme. Perfect complements mean perfect complements means what are the example? For example, tea and sugar complements. True. The tea and milk complements. Tires and tubes complements. True. Then the bank service, HNB service of HNB and service of the central bank complement services. So you have to follow the always we need a central bank, right? So the A and B, tea and sugar complements, tea and sugar. We know the cross price elasticity between complements negative. Last week we discussed negative. Now I am asking perfect complements. Underline perfect complements. X and Y perfect complements. Tea and sugar complements, that's true. X and Y perfect complements means, example again, it's a normal example, right shoe and the left shoe. Perfect complement. One right shoe, one left shoe. Two right shoe, two left shoes. Three right shoes, three left shoes. You don't have any use, you don't get any utility. One right shoe and two left shoes, no. One right shoe and three left shoes, no meaning. Always 1 to 1. One right shoe, left shoe. Then one gloves and the right glove and the left glove. 1 to 1, 1 to 1. There is no point now. One right glove and three the left glove, no. Only 1 to 1. In that case, either 1 to 2, 2 to 4. For example, the sugar and tea. In sometimes we ask when our visitor comes, when a visitor comes to a house, you ask, okay, these days especially people are always concerned about the sugar level. When we ask the question very politely, so how many sugar? Sir, do you like to have tea? Yes, yes, please. Then the second question usually asks, how many sugar? How many sugar? Sometimes we say, no, mata kahata vitarai, right? No sugar at all. Then in my case, I usually drink the kahata only because I am on diabetics, right? Therefore, I am very careful. So the then when I visit some my friend's place, always say kahata, right? Then, but sometimes one sugar, once one tea, one sugar, one tea, one sugar, always 1 to 1 ratio. Sometimes if you are too sweet, you love sweet, 1 to 2, 1 tea, 2 spoons of tea, 1 to 2, 1 to 2, 1 to 2, 1 to 2, 2 to 4, 3 to 6. Now in this case, if you take x-axis along the tea, cup of tea, and y-axis like the sugar. Now this guy is he loves the sugar. He prefers your 1 to 2. 1 cup, 2 sugar. 2 cups, 4 sugar. Like that. Always this dotted point. His equilibrium point, he moving along this the dots. Other points you don't have. Always fixed proportions. Fixed proportions. 1, 2, 2, 4, 3, 6, like that. Right? That is the shape of that. Indifference curve is right angle. Right angle, 90 degree. Right angle, always consumer moves from this first dot 1, 2 to 2, 4, 3, 6, the 4, 8, like that. you're moving along this line, no other lines, right? That is the example of perfect complements, right? Up to now, we have discussed the different shapes of this indifference curve. Next week, we will discuss budget line and the utility maximization using the indifference curve approach, right? Any questions, students? Yes, ladies and gentlemen, ask me any questions. We can spend another 5 minutes. Any questions? Understand? So I want you to go through this from the beginning. Work out. I have 2 examples. The example you have to work out, the marginal approach. Then MRS, you have to do the calculations, and you have to understand the difference between TU and MU using this example, the water Facebook example. So you can you can understand this example. Next week we will continue with this utility maximization using indifference curve, budget line, utility maximization, and last slide we discussed the application. Because the theory is there, theory without application is meaningless, right? We should be able to explain so many things. So next week we will discuss some of the application of this model. Please go through and be prepared for the next lesson. So we'll stop now.